Good morning, guys. I hope you all are good and enjoying my video lessons. Guys, today I'm going to discuss with you about the proofs of trigonometric identities. And before we start this, I would like to discuss about what is meant by basic angles, or it is also termed as reference angles. So we can say you all know about the acute angle. So the acute angle made with the x-axis is sometimes called the basic angle or reference angle. The point what is most important to note down, that is it is a kind of acute angle. You know acute angle, that is angle always less than 90 degree, and it must be made with the x-axis. That is called the basic angle or the reference angle. Here, for example, 1 or 2 marks question can be asked. Find the acute angle that the line, for example OP, made with the x-axis. Like here we are given 120 degree. We need to find acute angle. So if I can draw the line, 180, this is the first quadrant, this is the second, this is third, fourth, and this is 90, then 90, then 90, 90. 120 will fall where? 120 is more than 90. So if you start from here, because positive, so this anti-clockwise movement will be done. Suppose it is lying here, OP. This is O and this is P. That is 120 degree. But we are behind the acute angle, what we need to find. As it is very much clear from the statement that acute angle, here it will be the angle that is called basic angle, which is formed with the x-axis. X-axis here we have this one. So we are interested with this angle, this theta. So this theta is called as basic or acute angle. So as we know, the total sum of the quadrant with this case, let me check color, change the color. Okay, with this case here is 180 degree. So I can say acute angle or required acute angle, what we are looking for, required acute angle or the basic angle will be 180 degree minus 120 degree. So whatever is less, that is 60 degree. It means this angle is what? 60 degree. That is lying with the x-axis. So that is my answer. Take few more example to make more understanding. Say 430 degree. We know that the total sum of angles in the fourth quadrant, that is what? 360 degree. Yes, 360 degree total complete circle. So it is more than that. So as it is positive, so you need to start from here look at my orientation. Then till here we got 360. Wait a minute. I am going to start from here 360, but I need more. How much more from 360? You can see first 360 plus what, 70 will make you 430 degree, right? So it means once you start rotating from the anti-clockwise till here, then you need to proceed little up. How much up? 70 degrees. So I can proceed till here. So this is a whole representing the 430 degree. So what will be the basic angle? It means OP is lying here. OP is lying here, and we are looking for only this basic angle that's made with the x-axis. So we are behinding this. So as it is more than, it falls in the the first quadrant again. So as I have calculated here, it is 70 degree. After completing making a complete rotation, the angle becomes 0. It will initialize the circle at 360. So my basic angle, this is here what we call, that is 70 degree is the basic angle. I hope you got it. So required acute angle is equal to what, 70 degree. And how we calculated it? By using 360 plus how many more you need to rotate the angle. That is the answer. I hope. Okay, fine. Now for example, take another example that you are given. This part says C. You are given the angle is 3 pi by 4 in radian, and you have to find the basic angle or the acute angle in term of pi. So already in the last lesson we know that 180 degree was equal to pi radian. So pi by 4 becomes 40. So similarly, in pi by 4 becomes 45 degree, and 3 pi by 4 will be, you can check it, 3, because we are behinding this one, multiply 45, 135 degree, right? So think on where this angle 3 pi by 4 should fall. If you start from the axis positive, so if you start from the here, so I can say 135 is lying here, OP is here, OP is lying here. So this is what, 3 pi by 4. And what we have to find, the basic angle, that is the angle formed with the x-axis. So that is here, theta we are looking for. Total angle is what? We know that 180 degree is pi. So this is what, this goes to be pi. So I can say basic angle, or that is called acute angle, is equal to pi minus 3 pi by 4, that goes to be pi by 4, right? So this is how we can calculate the basic angle. And always keep remembering this thing, that you need to write the given angle at a certain coordinate and then subtract it from the given angle from the angle formed in that coordinate. Now guys, as we have to prove the trigonometric identities, before we prove it, let's take a triangle that we have a triangle ABC with angle C at right angled. This is what angle C. Here you suppose A, here suppose B. The side opposite to A is small a and B, C is small c and B is small b. Here, if the angle formed by the arm AC and AB, say that is theta degree, then we are well aware about the identities. Meaning, what are those? Saw, caw, taw. What these stand for? These identities shows us as for sine angle theta, that is opposite upon hypotenuse, opposite what A, and hypotenuse is what C from the figure, and caw mean cos theta, and that is adjacent is B or C. T stand for tan theta, that is opposite upon adjacent, that is A over B. From this figure we know that. You know, the most probably students get confused about this adjacent side. Adjacent side is the side which is formed by a line joining the right angle with the given angle. If this theta comes here at with B, then definitely my adjacent side becomes BC and opposite becomes AC. Yes. Now let's check it how to prove this. We can say that sine theta, you know, is A over C. Here, if you can apply the Pythagoras theorem by using Pythagoras theorem in right triangle ACB, we will get that is C square is equal to what? A square plus B square, right? So here, if you divide each term with C square, what will you get? This becomes C square over C square is equal to A square over C square. We will get this thing, and here the cancellation will taken place. 1 is equal to A square over C square plus B square over C square, or you can write this form as A over C whole square, B over C whole square, and 1. Now guys, as from the table formed above, we know what is AC. AC representing here, that is what? I'm circling it in. AC is equal to what? Sine theta. So here I can write it as sine theta square, and BC is equal to what? Cos theta. So this will be cos theta square equal to 1. So finally we have proved the one of the important identities of trigonometric, that is basic identity called as well. So that is sine square theta plus cos square theta equal to 1. So whenever we will have this form, sine square theta plus cos square theta, that can be equal to 1. From this rule, we can also extract two of the further identities, like if you want sine square theta, then with this identity isolate it and take the cos theta on other side, we will get sine square theta equal to 1 minus cos square theta, or sorry or or if we want to find the value of cos theta, so cos square theta will be 1 minus sine square theta. So with the help of this one identity, which you need to remember while doing the trigonometry questions, in mind that this can be further divided into two formula, that is sine square can be 1 minus cos square and cos square can be 1 minus sine square, right? One more important thing you guys you need to know, that is from this table tan theta. How can we find tan theta? That if you divide the sine theta and cos theta, in tan theta is what A over B, if you divide sine theta over cos theta, you will see that's give a new trigonometry, that is called trigonometric ratios, that is called tangent theta. We call it tangent theta. Theta is the angle, it can be x, it can be y. Generally theta, this symbol is going to be used in most of the books. So this is another identity which you need to keep in mind, and if you want to make the proof of it, then divide the two values, yani sine theta over cos theta from the above table, that was A over C over B over C. You will see C will cancel, we get A over B, and A over B is the ratio of tan theta. From the above table we can see even, right? Okay guys, along with these two identities, what we have proved so far, one is sine square theta plus cos square theta is equal to 1, and other one tan theta is equal to sine theta or cos theta. We need to know about three more algebraic identities that is very much important while proving the trigonometric identities, that are, I'm going to write here, a square minus b square can be written as 1 time plus a plus b times a minus b. This is third identity. This is algebraic identities, and you have proved in the O levels. And a plus b whole square can be formulated a square plus b square plus 2ab, right? You can insert 2ab in between or last, it doesn't affect it. And the final one, a minus b whole square equal to a square plus b square minus 2ab. Just keep these identities in mind, and on behalf of these five total, 1 2 3 4 and 5, we will prove each and every trigonometric identities, right? Let's see how. Take an example of the question. I wrote it here. That is one. Let's prove this question. Prove that 4 cos square of theta minus 3 sine square theta is equal to 7 cos square theta. We will take the left hand side, that is 4 cos square theta minus 3 sine square theta, and we have to prove this to the right hand side. Here we know in the answer, the right hand side is our answer. We have only cos square identity, cos identity. We don't want this sine square identities. So just if you go with the recollection of the concept, first prove sine square theta plus cos square 1, and from here we extracted out an identity that how to break this sine square. So sine square was equal to 1 minus cos square theta. So just replace it 4 cos square theta. So by applying this identity here, we can eliminate or transfer this sine square into cos terms, that is 1 minus cos square theta, and this we have. So now simplify it and you will get your proof, that is 4 cos square theta minus 3 plus 3 cos square theta. So plus 3 cos square and plus 4 makes you sine for 7 cos square theta, 7 cos square theta minus 3, that is your right hand side. So hence proved. You have proved this identity. I hope you got it. But keep in mind only the 5 identities but I have written highlighted here. The sine square theta plus cos square theta equal to 1 and tan theta is this and 3 algebraic. We will use everywhere this. Let's take another example. Let's we have to prove this time this identity. Tan theta plus 1 over cos theta whole square equal to 1 plus sine theta and 1 minus sine theta. We have to prove this. Prove that, right? Sorry. So take left hand side, and in order to prove this at trigonometric identities, even you can take your right hand side. If you think that is easy for you, you can take right hand side and make equal to the left hand side. It's the same. It will not deduct your marks. So here tan theta plus 1 over cos theta, but most probably we will prefer to go with the left hand side. So in the proof, we know the tan theta, this tangent theta. Tangent theta is equal to what? It was a ratio of sine theta to cos theta as proved before, 1 over cos theta. Whole square will be here. Now what to do? Take the LCM. Cos theta becomes the LCM and in numerator we have sine theta plus 1 whole square. Okay. Now distribute the power with numerator and denominator. In numerator 1 plus sine theta. Sine theta plus 1 is the same as 1 plus sine theta because my result is right hand side is 1 plus sine theta. So I just wrote it in that form. It doesn't affect and cos square theta. Now guys, we know cos square theta is what? Because in the proof we don't have a single term of cos, right? All are sine. So cos square theta, we proved it 1 minus sine square theta. And from which identity we got this? That we have proved sine square theta plus cos square theta equal to 1. So we can find out this one. So I am going to replace cos square with this form, 1 plus sine theta whole square over 1 minus sine square theta. Now see the proof. Proofs require 1 plus sine theta, so I'm not going to expand the numerator values, but in denominator we need 1 minus sine theta, not 1 minus sine square theta. So here you can see, let the numerator as it is, but denominator we can apply the identity. Think about the identities. Yes, a square minus b square will be 1 time plus 1 time minus. Students get confused about, we have the second square where the first term a square will be. So it's 1. So 1 square, 1 cube doesn't affect it. So it will remain 1. So I can put imaginary square here, 1 square minus sine square. So applying this identity, I will write 1 minus sine theta times 1 plus sine theta, right? So here you can see from the numerator we have the same term with the power 2. So this will be cancelled by this one and we will get 1 plus sine theta or 1 minus sine theta. That gives you right hand side. I hope it is clear. Let's proceed to another question. Well guys, now take an example that we have to prove the identity 1 plus sine x over cos x. This time instead of angle, that is theta, we have variable x as a theta, right? So take the left hand side as usual. Left hand side will be 1 plus sine x over cos of x plus cos x over 1 plus sine x. Here you can see, as we have to prove the result in the form of, this one, 2 over cos theta, only we need this. So single fraction, right? But in the question left hand side we have given 2 fractions, so write it in the single fraction by taking LCM we will get cos of x times 1 plus sine of x, and you are well aware about the LCM procedure that goes to be here and here. Now you just apply the identities. First expand it. The numerator, that a plus b whole square, we know that that was a square plus b square plus 2ab. As I told you before, this is identity I'm going to apply in the numerator to expand it. So let's see, 1 plus sine is 1 plus 1 square mean 1, so okay, you can write it, it doesn't affect, plus 2 times 1 times sine x plus cos square x, this cos square x from here, whole divided by cos x times 1 plus sine of x, right? So let's further solve the numerator. 1 square is 1, and this sine square and cos square I will write in the last, and plus 2 ones are 2 sine x plus sine square x plus cos square x. I'm going to write that in bracket because this reminds us an identity, the basic identity what we have proved, and let the denominator as it is, cos of x times 1 plus sine of x. Yes, what's come to your mind? This one, I'm going to write this whole is equal to what? This is equal to, yes, very true, that is, we know that sine square theta plus cos square theta is equal to 1. So this whole will be equal to 1. I will write 1 plus 2 sine of x plus 1 whole divided by cos of x times 1 plus sine of x. Now this one and this one makes what? This goes to be 2 plus and 2 sine of x over cos of x into 1 plus sine of x. From the numerator here you can see what looks to be common. Yes, 2 can be taken as common, so rest is 1 plus sine of x, and in denominator we have cos x times 1 plus sine x. Now it's pretty much clear that these two bracket terms from numerator denominator will be cancelled out, and you will get the result that will be, here I'm going to write, sorry, this is what, 2 over cos of x, that is was our right hand side, hence proved. I hope everyone got cleared it. Let's proceed to another next question. Here in this question we have to prove cos power 4 theta plus sine square theta cos square theta is equal to cos square theta. Theta is the angle again here this time. So let's start the question by taking your left hand side on task to prove it to the right hand side. So cos 4 theta plus sine square theta cos square theta, right? So what looks to be common from the first term and the second term? What is common? Yeah, very true, cos square theta can be taken as common, so rest is out of cos square theta plus sine square theta. And again it reminds us the identity that sine square theta plus cos square theta equal to what? Yes, 1. So this whole become 1, and you will see cos square theta times 1, and that is cos square theta, and this is what? Our required right hand side, hence proved. So before we proceed for the next question, I'm going to recall you guys that the five identities, yani sine square theta plus cos square theta equal to 1, and tan theta sine over cos theta, the ratio of, and 3 algebraic identities. You just need to keep this in mind, and each and every question, in order to prove that, apply these 5 identities to get your required result. Let's proceed for the next question. Okay, here we have to prove this 1 minus cos square theta or sin theta, cos theta is equal to tan theta. So taking your left hand side on task, right, sin theta times cos theta. We know again 1 minus cos square theta from the first identity, sin square theta plus cos square theta is equal to 1. So move this cos on the other side. So we'll get sin square theta is equal to what? Minus 1 minus sin square theta is equal to 1 minus cos square theta. So here I'm going to apply this identity. So this whole numerator equal to what? Sin square theta, and in denominator we have sin theta times cos theta. So you can see one sign will be cancelled out here. We have sin theta over cos theta, that will be tan theta, your right hand side, hence proved. Okay, okay guys, in this question again, take your left hand side on task. Generally we use left hand side to prove our right hand side, but it's up to you. You can take your right hand and prove it on left hand, but it takes little reverse calculations. So I prefer you to proceed from left hand to right hand. So there's tan x plus over 1 over tan x. We know the tangent x is the tan theta is the ratio of what? Sin theta to cos theta. So here this will become, this tangent become sin theta is here x, so over cos of x, and 1 over, what comes 1 over tan here, if you reverse the things, so it will be cos theta over sin theta. And later on I will tell you that this is become a trigonometry name, that is cotangent theta, but let it be, finish here. So this becomes cos x over sin x. Now take the LCM, because in the result we have to write in single fraction. So sin x to cos of x, it becomes sin square x plus cos square x. We know again sin square theta plus cos square theta is equal to 1, right, as we have proved it. So by using it here, these identities, the numerator becomes what? This whole becomes 1 over sin theta times cos theta, that is our right hand side. So hence we have proved these identities. I hope you got it. Let's proceed another question. Okay, so will be tan square theta over 1 plus tan square theta. So we know the tangent is the ratio of sin to cos. Tangent theta will be sin theta to cos theta. So I'm going to split this. It becomes tan square theta will be what? Yeah, it will be sin square to cos square. Right. Apply these rules in the given identities. 1 minus becomes sin square theta over cos square theta divided by 1 plus again sin square theta over cos square theta. Right, now simplify the terms from the numerator and denominator. What comes? This is whole divisor. Say we have the LCM here, cos square theta in the numerator, and that will be cos square theta minus sin square theta, and same on in denominator, cos square theta becomes the LCM, it will be cos square theta plus sin square theta. Okay, now you can see we have how many terms? one term in numerator and one term ratio form in denominator. So I can write it as cos square theta minus sine square theta divided by cos square theta. It's up to your convenience, you know. If you think you have a direct approach, you can do that. So here it will be divided by cos square theta plus sine square theta over cos square theta, right? We can write the above expression, the whole one, in this form, right? This whole will be, I can write this whole will be written as like this form, right? So here further we can solve it. Cos square theta will minus sine square theta over cos square theta and divided by, here what comes, this identity cos square plus sine square. Yeah, true, it is 1 over cos square theta. So now do the algebraic manipulation here. It will be cos square theta minus sine square theta over cos square theta. Division will change into multiplication, and by next term it will be flipped on. Here it's cancelled. We get cos square theta minus sine square theta. Now here you need to know that is the answer, but we have to prove that is based on only cos square term. We don't need sine square. So again, sine square theta is equal to what? 1 minus cos square theta. And from where we get it? From the identity sine square theta plus cos square theta is equal to 1. From here we can get the value of sine square. So after replacing it, here we will get cos square theta minus 1 minus cos square theta. You guys need to be very careful with the bracket, because this minus will change the sign, and you will see we get cos square theta minus 1 plus cos square theta, and that give you the result of 2 cos square theta minus 1, hence proved, right hand side. So you have proved this one. I hope it is clear. Okay, finally guys, we can solve this question as well. This again the trigonometry identities prove. Take your left hand side on task to prove your right hand side, because here we have two fractions and the result we have single fraction. So as per rule, we need to write these two fractions as a single one, like taking LCM. And you know the cross multiplication will taken place, sine theta plus 1 plus sine theta, simplify it, and in denominator you can apply the identity 1 time plus 1 time minus. What was the identity? That was a square minus b square. We can apply this identity in the denominator to write it 1 square minus sine square theta, and in the numerator you can see this is minus sine theta plus cancelled, 1 plus 1 makes 2, 1 minus sine square theta. Again, first identity, trigonometry identity, that was this equal to 1. So if you switch the sign on other side, it gives you the result of 1 minus sine square theta equal to what? Cos square theta. So I will write it with cos square theta. That's our right hand side. So hence we have proved this as well. So now good luck guys. You can go for the topical to solve more and more identities, and if you get any confused any questions, you get think that is going to be complex for you and you face any difficulty, do write to me or text me the question. I will explain you again, right? Good luck. Bye bye.